Hello everyone. We are having an interim session today to compensate for the missed session on 1st of April due to the medical emergency. I had to shift this session. So we are having to compensate for that session. We are going to have a session today from 6 p.m. to 8 p.m. We'll wait for 3-4 more minutes for others to join and then we'll start the session. I haven't yet uploaded the last recorded session video on YouTube, the session that we conducted on last Saturday. I have not yet uploaded it on YouTube. What I'll do is I'll also record this today's session and then I'll upload as two separate videos today only. Uh, so that and I'll send it to you. The links will be given to you in the next week. I mean, the coming session that is going to be on Saturday, this Saturday, the coming Saturday. So this is session number 10. So I'll be uploading the session number 9 as well as 10 today itself, and then I'll be giving you the links on in the 11th session that is going to take place on this Saturday. All right. I hope my screen is visible. Can somebody raise their hand and confirm? Yes, Dr. Satish, I have allowed your mic. Can you please confirm if my screen is visible as
Yeah,
well as it is changing?
it is visible. It is visible.
Okay. Thank you. Okay, hello everyone. I welcome you to the weekly discussion and doubt clearing session number 10 of the NPTEL course Maintenance and Repair of Concrete Structures NOC23-CE06, which is taken by Professor Radhakrishna G. Pillai of IIT Madras. I am Ashirvad Satpathy. I am a PMRF Research Scholar at IIT Delhi, and I am also the officially assigned teaching assistant for this NPTEL course. What I do is I usually take these weekly sessions where we discuss uh, the last week's assignment problems that you have already submitted the answers of, and we also take some of the doubts that you might be having regarding the previous week's lectures. There is another officially assigned TA to this course. His name is Umesh. He usually takes his weekly sessions on Fridays from 7 to 9 p.m. And I take my weekly sessions usually on Saturdays from 6 to 8 p.m. Today, we're just conducting an interim session to compensate for the session that we missed on 1st of April. And also, as I mentioned, I'll be uploading the last week's and this session's lectures on YouTube soon, and I'll be sharing the links in the next session. All right. In today's session, we'll be discussing the week 9 assignment 9 problems. There are around 8 problems, and these were related to different repair and rehabilitation and as well as retrofitting techniques related to shear failures, related to flexural failures, and other types of failures of various structural members. And these questions are more or less related to those repair and rehabilitation or retrofitting strategies. And then at the end of the session, if you have any doubts regarding the week 9 lectures, I'll be able to take those and we'll discuss them. All right. The first question was select the repair methods that can be considered as active strengthening methods for existing structural members. Gluing, and we have to select the active strengthening methods, right? Gluing of unbolted steel plates underneath roof slabs of a building, gluing of unstressed FRP composite laminates underneath slabs, post-tension GFRP sheets underneath beams to prevent deflection. Which of these are the active strengthening methods that you would want as the repair methods for existing structural members? Can somebody answer to this question?
I
Yes,
would
Dr.
like to
Satish.
answer.
Yeah,
Another
go ahead.
participant is there, Samiksha Dhote. In case she is interested, she can attempt. Samiksha, madam, would you like to reply?
It's okay, Dr. Satish. If somebody
Okay,
wants to answer, they can raise their hand. Yes, Samiksha, you want to attempt?
okay.
Yes, sir.
Yeah. Do you want to answer to this question? Do you want to try?
I thought the post-tensioning GRPF sheets.
Okay, this is the correct answer. And why do you choose this over the other two methods that are listed?
Mm,
Yeah,
was
this is
used
the
in the
correct
lecture.
answer. Pardon?
I would like to supplement.
Yeah, Dr. Satish, go ahead.
Uh, this is active system because
Yeah,
straight away it looks after the problem,
yeah,
whereas the first and two options come in picture when failure has taken place. So those
right,
are categorized as passive systems of protection.
right. Thank you, Dr. Satish. Thank you, Samiksha, also for attempting to answer this question. Yeah, so these two systems are passive strengthening systems. These are passive strengthening systems, as also discussed in the lecture slides as well. Whenever you're gluing a steel plate or an FRP composite sheet or a textile beneath, and as this is also mentioned over here, underneath or beneath a slab or a flexural member, these systems come into action only when there is excessive deformation or the deformation has gone beyond a certain level, and then only these elements will be able to take the loads or share the loads. But these are only called passive strengthening systems. So these systems these systems share the load when the load or deformation exceeds a certain level. So they don't directly, as and when they're installed, they don't directly take part in the load sharing process. Rather, they wait. These are protective state systems. So these structural systems only share the load when the load or the deformation has exceeded a certain level and there is excessive deformation, and now the structural system, the structural element itself, like the beam or the slab itself, is unable to take any further loads. Then these installment of these FRP laminate sheets or these extra unbolted steel plates beneath, as in the tension zone. So whenever you're providing these tensile sheets or these sheets beyond at the tension zone, they'll be able to share the tensile load and they'll be able to take any extra load that is coming onto the slab or the flexural member after the capacity of the slab or the capacity of the flexural member is exhausted. So therefore, these are called passive strengthening systems. But in this question, we have to select an active strengthening method, and therefore post-tension method, post-tension GRP sheets are among the given cases. These are the only ones which will directly take part in the load sharing process, as these are post-tensioned, and they will be they will be grouted as well. So they'll be directly in contact with the concrete, and therefore whenever the load is applied after the installment of these post-tension GFRP sheets, so they'll be directly able to share the load along with the flexural member. GFRP is glass fiber reinforced polymer. These are essentially brittle in nature. They don't undergo a lot of elongation. However, they increase or enhance the tensile capacity of these systems. So they impart ductility to the system. However, they themselves break in a very brittle manner, but they enhance the tensile capacity of the flexural members. So these are active systems. Active strengthening methods. As post tensioning is done, right? So the answer to this question is post tension GFRP sheets and then beams to prevent deflection. Moving on to the second question, a commercial building in use has to be upgraded to improve its seismic resistance. Choose the most appropriate terminology of this type of intervention. And the different terminologies have been given: repair, restoration, maintenance, rehabilitation, retrofitting, or stabilization. Which of these terms would you assign to this kind of a situation? A commercial building which is already in use has to be upgraded. The keyword over here is upgraded to improve its seismic resistance. Can somebody answer to this question?
Retrofitting.
Retrofitting. Okay. Thank you, Shamisha. Why would you choose that, and how is it different from the other terms?
Retrofitting means when you upgrade the existing structure
Mhm.
to improve its properties.
Right.
The
Okay.
chart explained during the lecture,
Right.
bar graph type. So
Right.
when you upgrade the existing structure.
Thank you. Thank you, Samiksha, for answering this question. Yes, this is the right answer actually. I'll go over all these terms one by one, and we'll discuss what they essentially mean and how do they apply to different cases of repair and restoration of repair and maintenance of concrete structures as a broader topic. So first of all, repair, and as it has already been discussed in the lecture as well, repair is something is done when there is damage. So there is damage or deterioration. And again, these two are different mechanisms, damage and deterioration. Damage is could be due to accident, like fire or impact load or blast, etc. And deterioration could be due to corrosion or deterioration of concrete or concrete deterioration. And so due to these mechanisms, already the structural performance of the system has gone down. Structural performance is significantly low, and therefore you can do a repair work. So then only we want
Uh,
repair.
I would like to I would like to supplement something.
Yes,
One
yes, doctor.
German expert has written a book on deterioration of materials. He
Okay.
says that this is a general term not only for concrete, for all the materials, timber and all these things are covered by him.
Right.
So as per him, it is a general term. Any deterioration he calls as uh, 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 any material can deteriorate.
Right.
So it's not
Since
specific
we
to our system.
Right. I
Yeah.
get it. Yeah. So you're talking about timber. Any system can actually deteriorate. Since we are only in this subject, we are only focused about repair and maintenance of concrete structures. So I'm talking in terms of concrete and reinforced concrete structures rather. So yeah, but anyway, deterioration can occur in any material. So with age and with the increased duration of the performance, I mean the serviceability of the structure, it will tend to deteriorate due to the different systems, due to the first due to aging, due to continued loads, and due to environmental effects, due to the surrounding environmental changes also, it will tend to deteriorate. And this is true for any material, but we are talking in terms of concrete and reinforced concrete structures. So these are the two major mechanisms by which the concrete or reinforced concrete structures deteriorate. One is damage that might be caused due to a sudden accident or sudden reduction in the structural performance of the material or the structural system. That could be due to fire or impact or blast loads. And then there is deterioration. Deterioration could be a prolonged phenomenon in which it can take these several processes can act on the concrete structures at once or in combination over a prolonged period of time, and they can therefore reduce the structural performance of the system. And once the structural performance is reduced, then we can carry out a repair work. So that is when we see that the structural performance is quite reduced from the normal original performance, and then we carry out a repair work. But again, repair work won't give you the original performance. So I would like to add one more element: won't give original performance. Right? So repair work is just enhancing the structural performance to its normal level of. As we have also seen in the lecture as well, with the passage of the time, let's say this is the original performance, and with the passage of the time, the normal structure tends to deteriorate, and this could be due to normal deterioration processes and aging as well. So this is the actual performance. But due to certain kind of accident, the structural performance could be suddenly reduced. This is a sudden reduction, and the enhancement of this reduction to the actual performance level is known as repair. Right? So this is repair. Then comes restoration, and restoration is, as the name suggests as well, restored to original performance levels. And this is typically, you might have also heard this term, restoration work, in the case of monuments or very old structures, restoration of monuments. So what they essentially do is they don't carry out a repair work just to suffice for the structural performance. Rather, the structural performance is increased, as well as aesthetics are also restored to the original levels. Restored to original levels. So as the structure has to be enhanced to such a level that it will be exactly of the same performance and of the same look and aesthetics as it was before, when the structure was actually constructed. So this is known as restoration. Then comes normal maintenance. So maintenance is you have to maintain the structure. Oops, sorry. I just lost it. Sorry. Oh my God. I lost everything. Anyway, I'll just highlight it instead of going in detail. Okay. Sorry about it. I lost all the annotations. I don't know how. So repair is, yeah, could be due to damage or deterioration, damages, accidents like impact, fire, etc. Deterioration could be corrosion, concrete deterioration, and this leads to a sudden reduction in structural performance, and then comes repair, which is enhancement but not to original performance levels. Not to original performance levels. This is known as repair. Then comes restoration, and as it suggests itself, restored to original levels. This is typically termed in the case of restoration of old monuments, structural performance, as well as aesthetic performance. Like new, right? Then comes maintenance. Maintenance is maintain the structure, maintain the structural performance, and this is typically low cost, and it only we have to ensure that structure is serviceable. We don't add a lot of external elements. We don't carry out a lot of repair or uh, take up various repair strategies or enhance the strength carrying performance of the member. Rather, we let the structure to deteriorate on its own terms. However, we just prevent it from a from an accelerated deterioration. So preventing an accelerated deterioration. We just ensure that the structure is serviceable. It is these are small. This could be just small strategies by like applying the regular waterproofing coats over the buildings, which when they get deteriorated, or painting of your metal elements, and these are just to ensure that whatever the condition that we're providing to the structure will let that structure deteriorate on its own terms with the aging process, but we won't let this deterioration to accelerate. So we'll prevent the accelerated deterioration. This is known as maintenance. Then comes rehabilitation. And again, rehabilitation is similar to repair. It is only degree of repair is much higher. So the structure has is not probably not under serviceable conditions, and therefore it has to be enhanced. It has to be enhanced to serviceable conditions. The structure, this could be again due to some accidental elements like impact or fire or blast, and the structure has gone beyond serviceable conditions. Like some of the structural elements are severely deteriorated or damaged. Some of them have lost their structural performance or the structural load carrying capacity, and therefore we are just repairing those elements. We're just rehabilitating the structure as a whole so that it will become serviceable again to serviceable condition. This is known as rehabilitation. And then comes retrofitting. And retrofitting is addition of features to enhance the performance. So what essentially happens in the case of retrofitting is that I'll show it over here. Let's say this was the original performance, and the structure was degrading like this. This is the natural or actual performance. Now what we did was we increased the performance requirement limits. Increased performance. I'm coming short of space. I'll go to the next page and do this. So let's say this was the graph. This is time and this is performance. And this used to be the original performance till certain period of time. Right? This was the original level of performance. And this was the naturally deteriorating performance. So with the passage of time, the performance level was actually getting lowered due to natural processes. Now what we did was we enhanced the performance limit, and this is the enhanced performance limit. And then we carried out retrofitting. So initially we carried out retrofitting so that the performance reached the requirement level, and then it started to degrade on its own. Retrofitted performance. So this is what is known as retrofitting. So this could be due to, let's say, as we have also discussed in the lecture, retrofitting could be done when this is a very old structure and the structure is still serviceable, working perfectly fine, but we have to conform with some of the new requirements that have been included in the structural design. Let's say the structure is not adequate to take the earthquake loads now. So as per the new guidelines, we have to redesign or add some external features to the structure so that it will conform with the requirements of the earthquake design. Similarly, let's say we want to carry out some new construction of another floor above the existing structure. So there is let's say a several storied structure, let's say 2 or 3 story structure, and we want to further increase the another story on top of it. Then we have to carry out some additional changes. We have to, let's say, increase the column sizes by concrete jacketing. We might have to increase the size of the foundation members. We have to add several other new structural elements like columns and beams. We have to add tie beams to connect it with the existing structure. So these kind of we are adding new features and new elements to the structure, so that we are thereby increasing the performance requirement. So the performance requirement was somewhere here, it was lower, while now we want it to take the load of another extra story. So we are increasing the performance requirement, and thereby also we are strengthening the structure to meet the new performance requirements. So the structural performance is enhanced to the new levels, and thereafter it will tend to, with the passage of time, the performance of the structure will tend to deteriorate due to normal aging processes. And this is known as retrofitting. And coming to stabilization, stabilization is again when there is there is deterioration processes occurring in the systems, like the concrete deterioration or corrosion of the steel reinforcement. And if we do not take care of the systems at this current stage, then it will lead to a severe deterioration and severe loss of performance. Therefore, we have to stabilize the structure. We have to add stability to the system, and so that we have to check or restrict these deterioration processes from further accelerating, and thereby reducing the structural performance beyond the actual performance. So stabilization is more or less again similar to repair. But in this case, only what we do is we have to install certain systems, or so that the deterioration processes that are already occurring, they might be restricted or checked at the levels that are at the constant at the contemporary levels. So whatever level of deterioration has already taken place, we'll have to stabilize it, or we have to check it or restrict it at that level so that it will not accelerate to further accelerate any further, or it will not reduce the actual performance. So stabilization is again different. In this case, since a commercial building, it has to be upgraded, and it is the keyword as I have mentioned. It has to be upgraded to improve the seismic resistance, let's say by adding certain extra members or adding shear wall elements. So it will have better seismic resistance, or you might want to go for a base isolation system in this kind of a building to take the lateral loads and isolate the superstructure from the base. So these are all retrofitting processes. All right. Moving on to the third question, choose the least appropriate statement regarding the selection of strengthening and stabilization methods. Only short-term compatibility between the old and the new material has to be ensured. The accessibility and feasibility of the repair work has to be considered before selecting a repair strategy. The repair method has to be selected based on the residual life cycle cost. Which of these is the least appropriate statement regarding strengthening and stabilization methods? Can somebody answer to this question? We have to select the least appropriate statement regarding strengthening and stabilization methods. Yes, somebody wants to answer? All right. Actually, the answer to this question is the first option. Only short-term compatibility between old and new material has to be mentioned. This is the wrong statement actually. So this is the least appropriate because whenever we are carrying out any repair or a strengthening work of any structure, then we want that this repair work has to go for a long as for a period of time as long as possible, so that we do not have to repeat this repair work within a very short span. Because whenever we're carrying out any repair work or any maintenance work or any strengthening or stabilization strategy methods, then essentially these methods entail a lot of costs. They can not only the cost at the time of installation, but also during the life cycle, during the life cycle of the repair, during the lifespan in which the repair will be effective. So whenever we are carrying out any repair work, we have to again main, ensure the maintenance of that repair work. Let's say we have carried out some patchwork, or we have carried out some jacketing, concrete jacketing, or we have uh, provided some steel plates at the underneath the surfaces of the flexural members. Then these repair systems have also will deteriorate with time, and therefore they will also further require some maintenance work, and that will again add to the cost of the total life cycle of the repair work. So what we want is we want a good compatibility between the the substrate material and the new material, which is the repair material, so that the repair work will be effective for a long period of time. Therefore, this is the wrong statement, and this has to be given the this is the least appropriate in this kind of a situation. The accessibility and feasibility of the repair work has to be considered before selecting a repair strategy. This is right, because this has to be given due consideration. Whenever there is a repair work, we're carrying out a repair work, it needs to be accessible, so that if we want to carry out further maintenance of that repair work that has already been carried out, then we'll be able to do that with much ease and without having much difficulty. And then there is the repair work should be feasible as well. It should be economically feasible as well as technically feasible. So the kind of repair work that we are going to carry out should serve the purpose and should be selected only when we know that what is the root cause of the problem that we're trying to address over here, and then only we will be able to select the repair work. And the repair work should be such that it should have as less cost as is possible in that case. So among all the repair strategies, all the options that are available to us, will be selecting only the repair strategy that will ensure that the cost will be minimum. And then the last one is the repair method is to be selected based on the residual life cycle. As I've already mentioned, yes, this is not just regarding the installation cost of the repair. Sometimes the installation cost might be very low. However, the repair work might itself require a lot of maintenance work, and that will increase the total cost. So, on the other hand, if we select a very high cost repair work also, then also there is no surety that it will not entail much cost in the due course of, or in the due passage of time. So therefore, based on the engineer's judgment and based on the requirement at that site, at the location, proper location, and the environmental conditions, as well as all other aspects of the situation, we have to select a repair strategy which has the minimum residual life cycle cost. So for the residual life cycle cost, as in for the duration that we expect the repair work to be effective, it should have the minimum life cycle cost. So this is again this statement has to be given due consideration when selecting. So the answer to this question is short-term compatibility is least appropriate, and therefore we want a long-term compatibility actually. This is the right answer. Moving on to the fourth question, it is essential to seal all the existing cracks using epoxy before strengthening a structure by external post tensioning. The sealing or filling of cracks may help even distribution of pre-stressing forces. Is it a true or a false statement? Can somebody answer to this question?
I'm the only one left out.
Yes,
Madam, you
Doctor.
already left.
Okay.
So this is true.
Yeah.
We have to fill up the cracks and then do post tensioning. Otherwise, there will not be even distribution of pre-stressing
Right. Right.
forces.
Right. Thank you. Thank you, Dr. Satish. Yes. So, when all the existing cracks are filled with epoxy before strengthening, filling the cracks with epoxy ensures even and uniform distribution of stresses distribution of stresses between the new and the old material. Because after strengthening, we'll not be able to fill it with epoxy, and once the strengthening has been done, and if the cracks are not filled properly, then there will be uneven distribution of the stresses, and that will further lead to stress concentration and further cracking or failure of the structural member. Therefore, we want all the cracks and the voids to be filled. Not all the voids, actually, all the cracks or the structural deformities that are on the surface of the structural members, they need to be filled with epoxy before the strengthening has to be done, so that once the post tensioning is done and it is released, the tendons are released. So there will be compression in the concrete, and therefore the cracks that have been already filled with epoxy, they will due to the compressive strength and stress in the concrete, they will be further strengthened, and that they will act as a part of the concrete itself. So there will be even and uniform distribution of the stresses between the new and the old, uh, I mean the concrete and the existing concrete structural member and the post tensioned tendons. So this is a true statement. Moving on to the fifth question, on the girders of a highway bridge, diagonal cracks were observed near the piers or supports, as shown in the figures. As you can see over here, there are diagonal cracks near the piers. So, among the given choices, choose the most appropriate repair strategy to strengthen the girders. These are some of the strategies that have been listed. External post tensioning using CFRP straps in the longitudinal direction, wrapping the girder end regions with CFRP laminates or straps in the transverse direction, base isolation of existing columns, bonding steel plates to the underside of the girders. Which of these strategies would you choose to reduce the effect, the or the appropriate repair strategy to take care of these diagonal shear cracks at the location, at the pier locations? Yes, Dr. Satish, you'd like to answer? All right. The answer to this question is wrapping the girder end regions with CFRP laminates and straps in the transverse direction. So essentially, first of all, the first statement is external post tensioning using CFRP straps in the longitudinal direction. In a longitudinal direction and post tensioning using the CFRP straps, that will take care of the flexural load carrying capacity. And since there are diagonal cracks, these are a sign of shear cracks. So this is not the answer. Since this will take care of the flexural load carrying capacity. Then wrapping of girder end regions with the CFRP laminates in the transverse direction. Again, yes, transverse direction is required because as we know, To take care of the shear, stirrups are also given in the transverse direction. So this will give us a stirrup action, and so wrapping it at the girder end regions, because at end regions shear is high. So this is a effective strategy to take care of the shear cracks that are the diagonal shear cracks that are occurring at the uh, piers or the support regions. At the support regions only the shear is high, the highest shear is at the support, and therefore it requires further strengthening. So if we provide the CFRP laminate straps in the laminates or the straps in the transverse direction, they will give us a stirrup action, and uh, therefore it will give us a good repair. This can be considered as a good repair strategy in this kind of a situation. Again, base isolation of columns is not required. This is for earthquake loads, earthquake loads, and no effect on shear shear capacity. They rather have an effect on the lateral load carrying capacity, not rather the lateral load carrying capacity. They rather reduce the stresses due to the lateral loads by isolating the superstructure from the base. So this is not an effective strategy. And then bonding steel plates underside the girders. Again, this is for flexural performance, to enhance the flexural performance. So bonding the steel plates will give you an additional section of steel which will be able to take the tensile loads. So this will enhance the flexural performance of the girders, not the shear performance. So the answer to this question is the wrapping the girder end regions with CFRP laminates in the transverse direction, right? Moving on to the sixth question, punching shear resistance of a column slab joint can be enhanced by, and which of these options are correct? Confining the column using FRP laminates, increasing the effective cross-sectional area of the critical shear plane vertical of the slab, providing collars and column capitals, providing drop panels. Which of these options is correct in case of punching shear resistance of column slab joint? Yes, can somebody attempt? Is Dr. Satish, you want to try? All right. Answer to this question is increasing the effective cross-sectional area, providing collars and column capitals, and providing drop panels. So, what is punching shear resistance? I'll try to explain you. Whenever there is a column, this is a column, and I'm showing a cross section, and then there is a slab. So this is, let's say, this is a column, and then there is a slab element directly. So this is a flat slab directly resting on the column. Then what essentially occurs is this column, there are cracks formed since the column dimensions are very small as compared to the slab, and the slab thickness is also small. So the cracks are formed in this manner at the column support locations. There are diagonal shear cracks, and these sides tend to come for downwards, while this sides is remaining intact. So there is a punching shear, or the column location only punches through the slab, and therefore there are cracks occurring at these locations. So this is known as punching failure. And the critical location is at a distance of d by 2, the critical location of punching or the critical region, critical shear plane is at a distance of d by 2 from the face of the column, where d is the side of the column, right? D by 2 on all sides, and this is the critical shear plane or the plane at which the shear is maximum. This is the location at which there is maximum risk of the punching cracks. And therefore, what are the effective strategies to reduce the risk of this punching failure or enhance the punching shear resistance of the column slab joints? Is by providing extra capitals. So what can be done is, if this is a column and then you're providing a capital, column capital or drop panel, what they essentially do is they enhance the cross-sectional area. Sectional area is enhanced. So let's say, since we cannot increase the depth of the slab sometimes, since it is constrained, so at that column location alone, we provide an extra slab-like element, which is known as a column capital or a drop panel or collars, and this can be of different designs and to enhance the aesthetic view of the columns as well. So we just provide a column capital or a column collar, and what they do is they increase the depth of the slab at this location. So the depth is increased. This used to be the earlier depth, while the depth is increased, and therefore at the critical shear plane, the effective shear cross sectional area is increased due to depth increase, right? So I've taken some examples. These are some certain different types of column collars that are given in different shapes and different designs. Then these are some capitals that we used to have in our old monuments as well, in very ancient structures. These are certain capitals, and if you look at these locations, just at the end of the column, at the bearing surface with the slab, they have an increased area so that the punching shear stress will be reduced. So the area is increased, as well as they also increase the depth of the slab at that location, so that the cross-sectional area, the effective shear cross-sectional area is also increased. So the total punching shear load or the effect of the total punching shear load will be reduced. And these are some of the drop panels, examples of drop panels that are given in probably a parking area with columns and flat slabs. So these are the different types of uh, strategies that could be adopted to increase the punching shear resistance or to reduce the risk of punching shear failure in a column flat slab joints. So the answer to this question is increasing the effective cross-sectional area of the critical shear plane. Yes. Then providing collars and column capitals and providing drop panels, they also what they do is they increase the effective cross-sectional area by increasing the depth. Also, they increase the cross-sectional area for the punching shear. So the punching shear stress itself is reduced. So these are the two effects of adding collars and column capitals. Right? Moving on to the seventh question. Introducing shear walls between columns and beams can help in enhancing the following: moment resisting capacity of the beam column frame system, resistance to the settlement of the footing, lateral stability of columns, earthquake resistance of the building system. Which of these options are correct with respect to shear walls between columns and beams in structural systems? Yes, Dr. Satish, go ahead.
This first one is okay, moment resisting capacity is enhanced.
Right.
Then it has nothing to do with the settlement.
Right.
Lateral stability of column, yes, it is enhanced. Earthquake resistance of the building system, yes, it improves.
Thank you, Dr. Sud. Yes. So I will take the help of this picture to explain the action of shear walls in a structural system. So shear walls are basically uh, reinforced concrete walls between columns and beams. And what they essentially do is they can share the load, the lateral loads coming onto the structure with the columns. So whenever there are two columns, let's say this is a frame structure, and this is a frame structure, and there is a lateral load coming, then the lateral load is taken by the columns in this type of a structure, and the structure tend to sway like this, right? So this is the delta. But when we have a shear wall system, then in case of shear walls, these RC walls share the lateral loads with the columns and beams. So they have two actions basically. One is the shear deformation. So this is the shear. So this is the total delta that is coming onto the structure, delta 1, delta 2, and delta 3. So the total, this is the total sway that is occurring in the structure, and therefore the shear wall, not only the columns in this case, but also the shear wall also take part in the resisting the lateral load or the shear deformation. And then there is the flexural deformation. So due to the lateral loads as well, the not only does the concrete structure sway, but due to its stiffness as well, it tends to bend or buckle sometimes as a whole, and therefore the shear walls also can take increase the moment carrying capacity of the system or enhance the flexural performance of the total structural system as a whole. Therefore, yes, they enhance the moment resisting capacity of the beam column frame system. They enhance the lateral stability of the columns, and they enhance the total earthquake resistance of the building system. So these three are the answers, but they do not have anything to do with the settlement of the footing, because whenever there is a differential settlement between two footings, even if there is a shear wall structure, so let's say this is a column and this is another column, and this is a footing and this is another footing, and this is connected with a shear wall system. If this footing goes down, then also there will be cracks formed, diagonal cracks will be formed due to the differential settlement. So differential settlement will cause cracks in the shear wall systems as well, and therefore it doesn't provide any resistance against the settlement of the footing. Moving on to the last question of this assignment. As per the lecture, strengthening a wall by concrete jacketing will impart additional load to the structure, and hence the foundation also needs to be strengthened. Is it a true or a false statement? This is a very easy question.
Yes, yes, this is true because
Right.
it adds to the dead loads.
Yes.
So foundation is to be looked after.
Right. So since it is a concrete jacketing, and we know that concrete elements are heavy in nature, so they also add to the dead load of the structure, and therefore we need to ensure that the foundation is designed to carry the extra dead loads, right? So this is a true statement. Yes, whenever we are doing concrete jacketing, they'll impart an additional load to the structure, and therefore the foundation needs also to be, if the foundation is properly designed from the beginning, and it is there is sufficient room for additional load to be carried by the foundation, then we do not need need not be strengthened anymore. But if the foundation is not sufficient, does not have sufficient load carrying capacity for the additional load that is imparted in the system, then we have to further strengthen the foundation as well, so that there is no failure at the part of the foundation. This ends the questions of this assignment 9. If you have any questions, we'll be happy to take those. The session will go on till 8 p.m. So if you have any questions, we can take those. Otherwise, you can leave the session.
Well presented.
Thank you, Dr. Dr. Satish, were you able to attend the live lecture by Professor Radhakrishnan Pillai? It was scheduled probably on 8th or 9th, I don't remember, but there is a message regarding that. Were you able to attend that? Yes, yes, yes. All right, we're closing the session for today. We'll meet again on the coming Saturday from 6 to 8 p.m. Thank you.